There are two parts to the mill. The first part that I'll talk about is the head. The head consists of the spindle forward reverse switch, the e-stop button, the RPM adjustment dial and readout, the gold box on the left side is the power drawbar in and out buttons. Next is the digital scale, the coil handle and lock. And over to the right is the Axis DRO control panel. The second part is the table and the knee. That part consists of the Z power feed and hand wheel, the Y-axis hand wheel, the table, which the vise is mounted to, and the X-axis hand wheel.
Open the bottom drawer using the notch on the side. All the tools you'll be using are in this drawer, so leave it open.
Familiarize yourself with the hand wheels on the mill before you start machining. The X-axis hand wheel is located on the right side of the table. Extend the handle on the hand wheel and turn the wheel in both directions. Notice the number changing in the X on the DRO when turning the hand wheel. The Y-axis hand wheel is located on the front of the machine. Do the same with the Y-axis hand wheel as you did with the X. The Z-axis gearbox is located to the left of the Y hand wheel. It has a power feed option to go along with the hand wheel. Using the power feed saves time when moving the table up and down. To raise the table, lift up on the lever on the left side of the gearbox. Notice the number getting smaller in the Z on the DRO. To stop the feed, put the lever back in the middle where it started. To lower the table, push the lever down. Notice that the numbers are getting larger in the Z on the DRO. The Z hand wheel is generally used to make finer adjustments, such as setting the tool to the part, as you will see later in the video. Let's transition over to the DRO itself. The buttons on the DRO that you will be using are the X, Y, and Z, the numbers, and ABS set. Please do not use the arrows just to the right of the screen. The video identifies these arrows with a red box with a line through the middle of it. If you accidentally press one of the arrows and a green box appears on the screen, please notify staff. We will get you back into the proper screen. Failure to do so could result in damage to the part, the tool, and the machine, or all the above.
Clean the jaws of the caliper using a piece of paper and calibrate the caliper. Measure from the flat to the radius and write the dimension on your drawing. Use a rag and wipe the vise clean of any oil and chips. Place the rag back in the toolbox when finished. Please do not leave the rags on the machine. Place the parallels into the vise. Now place the part into the vise with the existing hole to the left and facing the solid jaw as shown.
Secure the part in the vise by turning the vise handle clockwise until the jaws are tight against the part. Tighten the handle firmly. Grab the dead blow hammer and firmly tap the part until the parallel is tight. This will ensure that the flat being created will be parallel and not tapered.
Before loading any tools into the spindle, ensure the quill is all the way up and the quill is locked. Locate the collet into the spindle by lining up the keyway on the collet with the key in the spindle. Place the end mill into the collet, holding at the bottom of the shank with your index finger and thumb on your right hand. Hold the collet up when holding the end mill in place. To the left side of the mill head is a gold-colored box with two buttons, labeled in and out. Firmly press and hold the in button. When pushed all the way in, the in button should almost be flush with the gold plate. This will activate the power drawbar to tighten the tool in the spindle. Be aware that the tool will rotate when the drawbar tightens the tool.
Adjust the quill stop by turning the stop on the threaded rod up or down. It also has a quick release button to bypass the threads. Set the stop at least an inch or so from the top. Unlock the quill, bring the quill down to the stop, and lock it again. Now turn on the digital scale and zero it.
Pull up on the Z power feed lever to bring the table up so the part is within an inch of the end mill. Using the X and Y hand wheels, position the part directly underneath the end mill. The part is now in position for the touch-off phase. Turn the spindle on by turning the switch to the forward position and adjust the RPM dial until the readout reads 1000. Turn the Z hand wheel clockwise to raise the table. Raise the table until the tool lightly touches off the top of the part. Use the X hand wheel to move the part away from the tool and shut off the spindle. Press Z on the DRO, type in the diameter of the part you measured earlier. In this case, I'll enter 0.937 and press ABS set. Next, I'll raise the table by 30 thousandths, in my case, up to 0.907. Note, do not cut down more than 30 thousandths at a time. Add cutting oil to the part, turn on the spindle, use the X hand wheel to slowly feed the part all the way across the end mill. The slower the feed rate, the better the finish will be on your part. Now raise the table with the Z hand wheel until the Z reads 0.876 in the DRO. Remember, no cuts more than 30 thousandths of an inch at a time. Add more cutting oil, turn on the spindle, and use the X hand wheel to feed the material across the end mill. This flat will be wider than the end mill, so we will have to move the Y-axis to remove all of the material. We can now remove the part from the vise and wipe it clean with a rag. Measure from the flat you just milled to the opposite side. You'll want to make sure your measurement is within tolerance stated on the drawing. Before starting flat 2, we'll take the parallel out, wipe it clean with a rag, then we'll wipe the vise clean and insert the parallel back into the vise. Place the part inside the vise, putting the flat with the existing hole facing the parallel and the hole still oriented to your left. Secure the part in the vise and use the dead blow to firmly tap the part until the parallel is tight under the part. Use the Z hand wheel to lower the table until the DRO reads approximately 0.94 in the Z axis. Turn on the spindle and use the X and Y hand wheels to position the part under the end mill. Raise the table using the Z hand wheel until the end mill lightly touches the part. Now move the part away from the end mill. The DRO and the Z-axis should read close to what you set the first flat at. In my case, 0.937. Add cutting oil to the part. Move the Z-axis hand wheel until the DRO in the Z is at 0.906. With cutting oil and the spindle on, use the X hand wheel to slowly feed the part all the way across the end mill. The slower the feed rate, the better the finish will be on your part. Add more cutting oil and use the Z hand wheel to raise the table until the Z reads 0.876 in the DRO. Remember, no more than 30 thousandths of an inch at one time. After removing all the material, move the part away from the end mill and shut off the spindle.
If the measurement is within the tolerance, raise the quill and lock it in place. Lower the table. Lower the table to give yourself plenty of room for the keyless chuck, the drill, and the tap. You should not need to raise the table after this step. Once you have about 6 inches of space, stop the table. Make sure the quill is all the way up and locked. With a rag in your hand, hold it below the end mill and firmly press the out button until the end mill drops into the rag. When pushed all the way in, the button should almost be flush with the gold plate. Load the keyless chuck by lining it in the spindle and firmly pressing and holding the in button. When pushed all the way in, the button should almost be flush with the gold plate. Now tighten the edge finder into the keyless chuck as shown. Next, lower the quill stop to give yourself enough room. Turn on the spindle and turn the RPM adjustment dial down until the readout is approximately 800 RPMs. We will first be finding the 0 in the x-axis. Bring the quill down so the spring portion of the edge finder is alongside the end of the part, as shown. The edge finder should be running out at the bottom. While looking down the x-axis, slowly move the X hand wheel so the part makes contact with the edge finder. Keep making small adjustments to the X hand wheel until the runout of the edge finder gets smaller and smaller and slightly breaks the other way. Raise the quill so the edge finder is above the part. Zero the X on the DRO. Now move the edge you just found to the center of the spindle by the radius of the edge finder, which means you should move the X hand wheel until the X DRO reads 0.25. Visually, look to see if the edge of the part is in the center of the spindle. If so, zero the X axis on the DRO. You just found the X origin. Now, we need to find the 0 in the Y axis. We will be finding the edge of the back solid jaw that the flat is up against. Bring the quill down so the edge finder is inside the solid jaw. While looking down the Y-axis, slowly move the Y hand wheel so the solid jaw makes contact with the edge finder. Keep making small adjustments to the Y hand wheel until the runout of the edge finder gets smaller and smaller and slightly breaks the other way. Raise the quill so the edge finder is above the vise. Zero the Y on the DRO. Now compensate for the radius of the edge finder. In this case, the Y value should read 0.25. Visually look to see if the edge of the solid jaw is in the center of the spindle. If so, zero the Y axis in the DRO. You just found the Y origin. Take the edge finder out of the keyless chuck.
Load the spot drill into the keyless chuck. Bring the spot drill down till it touches the top of the part. And zero the quill readout. Turn on the spindle and adjust the speed to 1000 RPM. Use the spot drill to a depth of 50 thousandths of an inch. Now remove the spot drill and put it back in the toolbox. Grab the drill and push it all the way up into the keyless chuck and tighten it down. Touch the drill to where you just spot drilled and zero the quill readout. Add some oil before drilling. With an up and down motion, peck drill the part until you reach -0.7. Remove the drill and put it back in the toolbox. Grab the countersink and load it into the chuck. For the countersink, lower the RPM to about 300. Use the countersink to create a chamfer around the hole. Remove the countersink and put it back in the toolbox. Grab the dead center from the toolbox and load it into the chuck. The tap has a square end while the handle has V-jaws. Fit the corners of the square into the V's in the handle. Turn clockwise to tighten down. Place the tap into your drilled hole and bring down the quill so the dead center fits into the top of the handle. Lock down the quill. Before tapping, add some cutting oil. While tapping, we will turn it 3 half turns forward and 1 half turn backwards. This will break the chips and prevent the tap from breaking. Continue making 3 half turns forward and 1 back until the tap reaches the bottom of the hole. You will know you reached the bottom when it gets difficult to turn. Once the tap hits the bottom, raise the quill and unscrew the tap. With the rag covering the hole, blow out the hole to remove any chips. If everything is done correctly, the thread checker, as shown in the video, should screw down so that the nut is flush with the face. Use the file in the forward direction to remove any sharp edges.
Use the part drawing to clean the jaws of the caliper. Zero the caliper. Notice, the part drawing has specified default tolerance in the title block, so all of your measurements should be plus or minus 10th of the specified dimensions. If your measurements are not within the desired tolerance, keep measuring. A staff member will later determine if you should fix, modify, or redo the part. Measure the length of the part. Your measurement should be between 2.99 and 3.01. Make sure to record your measurements on the part drawing. Measure and record the size of both flats. Your measurement should be between 0.866 and 0.886. Measure and record the diameter of the boss. It should be between 0.74 and 0.76. Using the caliper's depth rod, measure the boss length. When measuring, ensure the caliper end is parallel to the boss face and the depth rod is parallel to the boss's cylindrical surface. It should be somewhere between 0.74 and 0.76. Record your measurement. The final horizontal hole location should be within 1.99 and 2.01. To accurately measure this distance, you must take a total of 2 measurements. Do not eyeball the center of the hole or you will get an inaccurate measurement. First, measure the distance from the back of the part to the edge of the hole. Write your measurement down. Next, use the inside jaws of the caliper to measure the diameter of the hole and write the radius down, or half the diameter. So, if you got 1.9 for the first measurement and 0.1 for the radius, your final measurement will be 2. Grab the parallel. Zero the caliper on the thickness of the parallel. With the parallel and part in one hand, measure the distance from the flat of the parallel to the edge of the hole. Use the same procedure as before to find your final measurement. This measurement should be within 0.428 and 0.448. Remove any tooling from the spindle if you haven't already done so. Please note, you should not use an air hose to clean the machine. There is a risk of airborne debris injuring someone. Remove and clean any tooling in the vise jaws and use the rag to wipe the vise down. Use the chip brush to clean the sides of the vise. Remove the aluminum table covers and dispose of the chips in the metal recycling bin. Clean the rear weigh cover. Move the table all the way back and clean the forward weigh cover. Center the vise on the spindle and leave the vise slightly open. Shake out the mat. Sweep the bottom of the mill and make sure to clean out any excess oil. Sweep the mill surroundings. Place the mat back. Ask a staff member to check off your machine. You're all done cleaning. Please ask one of the professional staff members to grade your part, or if it's after hours, please create an appointment using the QR code on the screen or the link in the description.